corneal treatments. Because how many people in here really are not comfortable with hyperopic corneal treatments? That's it? Okay, let me try it the other way. How many people here are totally comfortable with corneal treatments on hyperopia? Right. So a lot of you don't have an opinion. You're not comfortable, and you are comfortable. Or I don't know what you're doing, but you're asleep. Anyway, the point is, there's so much folklore about hyperopic treatments on the cornea, and it's come from the fact that we've had a bad history with it. So when I was starting my fellowship, we had the NIDEC, and we were using it to do hyperopia. It was one of the first lasers to do hyperopia after the MEL. And we treated a lady +3, and at 3 months, she was +275. And we had no idea what was going on. And fortunately, I took my prototype high-frequency ultrasound scanner from Cornell to Vancouver, and I scanned this patient. Now, I couldn't scan the whole cornea at the time, so I had to do one half at a time. But you can see that is the flap interface. That is the stromal surface, right, Bowman's. And that is where we started from, right? That green line. So we were trying to, just going to work. So we were, we were trying to get down to where the red line is, but the white line is what the epithelium filled in. So you can see why there was regression of the curvature that we expected. Now this was, believe me, this is obvious to you now, but we had never seen anything like this, right? Because no one had looked at the epithelium before. So, obviously over the years, we've done quite a bit of research on this. And the first thing we did was to characterize the epithelial changes in hyperopic corneal treatments. Now, one of the folkloric things about the hesitation of doing corneal treatments for hyperopia is the Ks. You cannot, and that's kind of like a rule of thumb. And that's because, you know, if you're too steep, then the epithelium becomes, you know, a bit thin, right? But you see, what we learned was that it's not the corneal curvature. It's the rate of change of curvature. So here's an example of a patient treated on Invisics, programmed in a 6mm zone, but achieved a 4.5mm zone. So the rate of change of curvature for this +4 was huge. And so the epithelium became super thin, and it kept on sloughing, and she developed an apical scar. Okay? So in our study where we used MEL 80 and MEL 90 at 7mm zone, here's the epithelial profile. And you can see that in cross-section, the epithelium is very thick inside the trough, and it becomes thinner in the center. And the amount of thickening and thinning is proportional to how much hyperopia you've treated, and it's also proportional to the post-op K. But here's the most important slide. On the x-axis, you have the keratometry, and on the y-axis, you have the epithelial thickness. Now you see that the thinnest point becomes thinner the steeper the cornea, and the thickest point becomes thicker the steeper the cornea. In other words, the more you steepen it. But here's what you need to pay attention to. This eye has a keratometry of less than 42 post-op, but the epithelium is already at 26. The epithelium minimum does not want to go below 30. And actually 26 is really threshold for epithelial breakdown. I mean, an epithelial cuboidal cell is maybe 10, 15 microns in height. So you can imagine why 26 microns is kind of thin, right? It's like one cell or two cells. So there you have a patient who was a +150. He regressed to +1. And anybody would have done an enhancement on that guy. Anybody. Because the Ks are less than 42. But I didn't, because I saw that his epithelium was really thin, and I said, sorry, no more steepening for you. Whereas, here's what you expect. Here's a cornea that's 49K with a 26 epithelium. Okay, well, sorry, we can't do any more for you. But, how about this cornea? This cornea is 50 diopters, but the epithelium minimum is 44. I can do a plus 250 enhancement in that patient, even though the Ks are 50. And likewise this one, 52.6 K, but the epithelium is 36. I can do a 1.5 diopter hyperopic enhancement in that patient, because there is enough minimum epithelium to go. So the take-home message here is, number one take-home message, if you're going to do hyperopic corneal surgery, you have to have epithelial mapping. You have to have it, or you're going to get into trouble without realizing it. The Ks are not the best indicator, okay? The second most important thing that people need to know that is different about hyperopia from myopia treatments is centration. In myopic treatments, you get away with it because a little decentration on a myopic treatment doesn't matter. You're moving a trough around. But if you're moving a peak around, you have big optical problems. And so the question was, and this is started in 1997, we solved it for ourselves when we were doing these treatments with the NIDAC. But for another 15 years, this is still a debate on stage, and there's one laser platform that keeps on forcing everybody to treat on the center of the pupil, which is bonkers in 2024, but that's how it's built. So we designed a study where we can do it retrospectively so that we don't harm 50% of the patients. And the study basically said, patients that have 0 angle kappa, or we're going to call it patients treated in the center of the pupil, and patients that have a large angle kappa, more than 0.55 millimeters of offset, we'll call that the angle kappa group, and nothing in the middle. So there's a gap. So there's no overlap to screw up statistics. Now, by looking at the outcomes of these two groups, I treated all of them on the vertex, but the ones in the middle are pupil center. So if pupil center theory is correct, then the outcomes of the large angle kappa group should be poor, right? By definition, by physics definition. So what we did was look at the outcomes, and the safety, accuracy, astigmatism, and contrast sensitivity and night vision were the same between the two groups. And when we look at the corneal aberrations, the coma was the same for center of pupil to angle kappa centration. Which means, because obviously corneal aberrometry is measured from the vertex of the cornea, but the whole eye aberrations were worse. So the coma was much higher in the angle kappa group. So now you understand why, right? Because whole eye aberrations are measured from the center of the pupil. So according to a wavefront guided treatment, we screwed the patient up. But according to the clinical results, we did well. So you understand why hyperopic treatments have had such a bad reputation. Keratometry is not a good indicator of what you can do. And centration is visual axis, not center of pupil. And this is why the outcomes are all over the place. All over the place. It took more than 10 years for papers to start coming out stating that there's a consensus now that coaxially fixated visual axis reflex is the place to put ablations. And Visumax was designed to treat SMILE on the corneal vertex. That's how it works. They look at the green light and you accurvate the cornea and you lock. And you don't need a tracker and you don't need cyclotorsion control because you move the contact glass around. And with the 500, we get phenomenal results in centration. So if we look at the outcomes of hyperopic LASIK, which again, here's putting down the data on the paper so that people who say you can't treat the hyperopia on the cornea can be educated and maybe open their minds. This is 1,300 eyes, okay? Up to plus 650, and you see that 93% of the eyes were 20/20 before surgery, which means that 81% of the eyes that could be 20/20 were 20/20. And we had 0.6% loss of 2 lines. And that's with minification, because they see smaller. So it's really not a lot of loss of lines. Let's go one step further, because people say, I can't treat more than +3 on the cornea. It's like, okay, you can have your +3 forget about it, go and have a coffee. I'm going to go do +4 to +7. Forget about +3. +4 to +7. 830 eyes with 2 years follow-up. 76% 20/20, 0.4% loss of 2 lines. And the stability, as you can see on the stability graph, at 2 years is stable. So these ideas about, oh, there's regression, you can't do corneal surgery, it's all to do with a lack of understanding of the specifics of treating hyperopia in the cornea. So, where does that bring us? It brings us to talking about hyperopic corrections in the cornea again, and those of us who've been doing LASIK on the cornea for years, this is not a problem. To us, it's just shifting from flat to no flat. But for a lot of you, it's going to be, really? Okay. But actually, you can even start now with LASIK, because LASIK is a great procedure. Now, what's the history of this? Well, the first study on the sort of lenticule extraction was our friend Walter here, who, this was, done many, many years ago, and they were using small optical zones with very small transition zones. And so they got a lot of regression, they got a lot of loss of lines. And everyone thought, well, it's not going to work. But then it was like, wait a minute, look at the excimer laser. We use large transition zones and large optical zones. So again, did a pilot study on 9 eyes with larger optical zones with a 2 millimeter transition, much better stability. So then, again in Marburg, another flex study, 39 eyes with really good stability, and obviously using large optical zones with large transition zones. Which then brought us to, what we have now, which is, technically, it's a 6.3 millimeter optical zone with a 2 millimeter transition, obviously the lenticle side cut, an 8.8 cap diameter, 0.5 millimeters left, right? 6.3 to 8.8, sorry, 6.3 plus 2 is 8.3 to 8.8, that's 0.5, so you have 0.25 on each side, so it's very tight on the edge. 120 micron cap, we can talk about that, 24 micron minimum, 2 millimeter small incision, and the reserve incision. So we see so many surgeons still doing 1 incision. And you can do 1 big incision, but it's much better to do 2 small incisions. And in our textbook, we have 9, in our chapter, we have 9 reasons why a second incision is a good idea. So anybody who's still making 1 incision is missing 9 opportunities to improve their surgical lenticle removal. So what does this mean? Well, we started a study in Nepal with Kishore Pradhan after he finished his fellowship with us, and we found that the smile centration was actually slightly better than LASIK with the tracker. Well, of course, because it's fixed. Once you're on, whereas the eye is moving with LASIK. So you need a tracker. We found that the optical zones were way better than we expected. It turns out that a 6.3 millimeter smile gives you a larger optical zone on topography than a 7 millimeter LASIK. We'll maybe discuss later during the discussion. So the outcomes of this, we published the 3 months and then the 12 months, were phenomenal. This is a lot of amblyopia because it was a very high hyperopia. But you can see that practically the same number of patients were seeing 20/20 without spectacles as they were previously with spectacles. The accuracy was superb. You can see most of the patients were +6. So this was we were really going for it here, and these are people that wanted to go into the army because it's employment. And so a lot of these patients were +8, and they were 18 years old, but you correct them to +2, and then they're super happy. The accuracy was fantastic. The stability was excellent. The cyclotorsional control was excellent. The cylinder control was excellent. So we had this preliminary study in 1 center, and then came the multi-center trial, which we're going to hear about shortly. Thank you very much.
Thank you very much.